Well, first of all, thank you for this opportunity for us to um, have to show our uh, project, and thank you all for this. And we are team VGU from Vietnamese German University. I'm Nhật, and my teammates are Nguyen, Hưng, and Tiếng Anh. I think I will gonna share my screen. Our team is VGU Engineer Baron, which are engineering bears, and our project is on health data collecting module for Ohmni robot. We are planning to build a module to get it mounted and implemented on the Ohmni robot to collect participants' temperature and SpO2 ratio for controlling the pandemic at industrial sites and factories. With it, first we will come to the technology. Our modules will have such features like capturing facial region temperature, retrieving SpO2 ratio and heartbeat data, 3D printed mount, web server, and displaying can you guys see my feature screen?
Yes, well, we can see the feature, the main focus feature, right?
Yes. Okay. We are on the features, and I will do it again. We have some main features such as capturing facial region temperature, retrieving SpO2 ratio, 3D printed mount, and web server, displaying health data on the web server and Docker. We would like to have main focus on the displaying health data on web server because we are in process of developing it. We have not fully developed it because we cannot fully push the image, the facial image onto the web server. Later we will show you that. And Docker, we were inspired by Ohmni Robot Docker to contain all the nodes and features and modules onto Docker for to make more space and capacity. Next, we will have the hardware requirements. Here we are using the MLX 90640 for the thermal image capture, and the Max 3102 to capture the heartbeat, and the SpO2 sensor module. We firstly we use the Raspberry Pi cam to capture the RPG image, and the Raspberry Pi 3B to process the nodes. But now we have made it to we have been using the cam from the main cam from Ohmni Robot, and we are using the processor of Ohmni Robot to process the nodes. For the middleware, we are using ROS, Robotic Operating System, and software requirement. You can find the Docker on our GitHub link. This is the main focus I want to talk about. This is our structure for the project. We are connecting the USB cam, the main cam, and onto the USB port of Ohmni Robot, and we are connecting the two modules onto the ESP32, and we have we are using ROS serial to connect it to the USB port, and from the USB port we input it onto the Docker, and then we have a publisher to publish the face detection, which is a thermal, and we're using thermal module and OpenCV, and then we ROS bridge it onto the web server. This is our aim to for future development. We are going to have a database, but we haven't done it due to the lack of time. For the output, we are expecting a locally hosted website that display the, the, the data health. The current state of our project, we have developed the view server. We have built the thermal data calculation module and the retrieving heartbeat and SpO2 module. We have established the ROS bridge to display the SpO2 and heartbeat data and the main cam image. This main cam image is only the RBG image, not the fully set image that we are aiming to do, because the features we are lack of ROM, and we have built a Docker to contain all both features. Maybe I will stop sharing and do a new share because I have shared it wrong. Anh sẽ xem now I hope you can see my slide now. This is our UI for the interface for our web. As you can see, we have developed the heartbeat sensor. We have displayed it, and this is our thermal image that we want to display. And as you can see here, this is our expected output with a face recognition and the max temperature of the face region. This is our mount that we have developed for the Ohmni. These the challenges that we have faced in the past session. There is low FPS rate, and previously we cannot catch the temperature when participants are wearing glasses or face masks. But after firstly we propose such solutions that we can select a specific frame to display instead of real-time displaying for the low FPS rate, and for the other problem we want to resize the area of the thermal data taken. And after the private session with the team, we have developed such solutions. We have reduced the FPS rate. We are capturing now 11 frame after every 10 captures frames, and we are extending the bounding box contour and to capture only the max value in the forehead region. This 1/3.3 of box height, and we have been measuring and provide an optimal nominal distance, which is 40 to 50 centimeters away from the cameras, and all of these are the best solution that we have measured. But now we are encountering new challenges, new difficulties. That is the Ohmni robot ROM. We are lacking of space since the Ohmni robot has been used up all the ROM size, almost all the ROM size, and we cannot push our Docker fully onto it. The camera bandwidth limitation, and we cannot run both cameras, the main cam and the auxiliary cam, at the same time. The module we are using are just industrial technology for modules. They cannot meet the requirements for the medical devices. We will go to the proof of concept. I hope you can see the graph I'm sharing. And this is our current process. As you can see here, we have been able to push an image, a normal image, not the module that we have built, onto the web server, and we have also captured the SpO2 and heartbeat onto the web server. When your heartbeat is high, the blinking will be faster. Uh, this is our work log, and these are references. Uh, well, thank you for having some time with us.